keep this rotating so it's not taking all that heat load. So getting that close out of this. I kind of, this is my way. I kind of work my way across, down, and then I start here and go across. So it works. So if you had multiple, different functionality, we'd have different tabs. But you basically have a vacuum screen. These are all the vacuum related components, and deposition. And these are all embedded on here in a certain manner, so you can't take this and move it around. Within our software engineers, you may have like 5 other power supplies in here. So he puts the association. Okay. Once again, this basically matches the layout, source 1 and source 2. So RF is on source 1, power supply 1. This is the setup tab. This is where you can change the track targets. You go back here, you hover across here, it tells you it's power supply 1. And it's weird how they do this. Really how things are fit in space. You would think this would be 1, this would be 2. But it's how they fit within a rack. But they do have a number, 1 and 2. I don't try to understand why they do it.
I forgot. So the first one is DC, right?
Yeah. So this PD500, this is a DC supply, and this is the RF supply. Yeah. And these are all private labeled, so we don't make those. But they even tells you RF right here. And once again, you can just go to the source, which is highlighted in white here. And it says RF in the brackets, but if you even just hover over top of here, it says power supply 1 enable, so that kind of just leads you to it. Alright, so substrate heater, power control. I don't typically use power. Power control is kind of like the flow mode in the MSCs. You just put a % power in, it just takes off. And whatever, if you put 15% power in, whatever temperature you achieve, that's what you get. I like to use temperature control. Temperature control, you actually put a ramp rate in and a desired temperature, and then it gets up there nice and easy. So you shouldn't have to play around with temperature tuning. These are all the PID loops we had set. You mentioned earlier that this was checked here, that default, or the heater error in red. Whenever I hit the EMO, I think that's what might have triggered it. So I just hit this reset error, and that's what changed the state from red to white. Because when I tried to run that, I still had that at the error, and it prevented the heater from turning on. So somewhere up here, yeah, we got an interlock. So that's what's nice. So this annunciator bar, if I clicked acknowledge, every one of these would go away. If I go to messages, another pop-up will appear. I can filter the messages by all the messages. I can filter by any aborts, if I haven't cleared that, by any errors, by any interlocks. Okay. Oh, there was an interlock there. There's another one there. So I can just acknowledge the filtered messages and close it. I do that. Oh, acknowledge them all. Or you can just, so it's basically a running tab of what's going on. So run recipes pretty simple here. Whatever's in the showing the run list. We talked about categories. We go to categories. Recipe editor is how you get into the recipe database, and go ahead and close out of this. Go back to the list. All the recipes. You can import recipes. If you had another system that was running Eclipse, you can import it on a thumb drive. You can export it in XML format. That's how we get recipes in and out from our standard recipe libraries for consistency. But won't get into too deep on that. Recording setup's interesting. So there's 3 functions on this tool that use the same database per se, or functionality to record or display data. So we have this recording setup. We have a dashboard to chart. If you notice over here, there's a whole bunch of signals, available signals, and it's every signal which is on this tool that I have selected in our signal list to be either using recipe, interlock, or data logging. Will show up within this list here. I can take one here, highlight it, we're just generating a list of signals to be recorded, okay? This can be kind of cumbersome doing it in this manner because you have to scroll through the whole list. It may not be intuitive to what this signal does. So there's other ways to go ahead and do this. You can select the signals graphically. I like to do this. When I select them graphically, it suspends the touch screen operation. All right. And it just adds them in order. So touchscreen doesn't actually happen. It just puts them in the list. That's, to me, that's a lot easier. Especially if I want to go to the deposition screen and I'm like, okay, I want to run a film and, you know, RF, what do I want to do? I want to check out what my tune and load is, what my forward reflected and DC bias, what my set point, if we're on, if we have any, oh, we're already in there. If we have any issues here, phase errors, you know, that's easier than going through that list and saying, okay, what does this do? You can go through the list if you want. If you don't know the name of it, you can just hover over top and you'll get the pop-up box and then go back to the list. So this is much easier. This is the one I really try to push. Okay. So you go back to recording setup. Oh, here, return to recording setup. There we go. So I have this entire list, okay? So I can save these as a new set. I can highlight one of these and save it as a selected set. I can delete the set. I want to save these as a new set. I got a pop-up. All right, I'm going to put Brian's test. Okay, click OK, and it'll pop over here. So I'm going to go ahead and clear this list. If I highlight this, show the selected set, pops over there. So really what I've shown you is a whole bunch of signals that I just randomly picked. Those doesn't mean anything. We've already pre-selected some signals for you that you can keep or add or modify. So if you look at what's pre-selected, we have source 1 RF. So these are all the signals that are associated with it that we thought may be valuable for your data log. And this is included in the data log. So whenever we ran the recipe earlier, that master recipe, which was right here, you'll notice that step 2 was to run the recipe recording RF source 1 deposition. So if I go back to my recording setup and click refresh down here, this is my data. Oh, I want to open this again in Libre Office Writer. But here's all the data. So you can display it in this form. You can send it out to Excel. You can display it in a chart. Use a chart. I think you can only use 10 pens. You know, we don't have 100 lines, but you can use the first 10. But what's interesting about this is you notice all these recording sets here. And you call up a recipe, you can incorporate that in the recipe. You can also go down to what we call the dashboard. And I like to use this dashboard a lot. Especially if I'm not in the clean room. It defaults to the system pressure, what it defaults to. But I can have anything displayed in here that I want. What I like to do, if I'm working outside the clean room, I'll turn this thing around and I'm like, okay, my pressure, I don't have to get gowned up to come in. So it's kind of a nice feature. But I can go to the settings down here. Now I can go select a recording set. And I can select these, and these are all the things that I just selected. You can show them in the dashboard. You can also do these things, and I have like I think a 19-page quick start guide that tells you how to set up a chart. You can also show these in the chart. So in the past we've had multiple functionality on how you set up the recording, the charts, and the dashboard. But in reality, if you use the same data set in a table, it's much easier to manage and much easier to understand and train out of. So that's what we like to use. So once again, the chart, I can go to the settings here, and I'm just going to go to save sets. If I click this, it's going to show the first 10. And maximum 10 signals, first type thing to be recorded. So we use this. Let's say we want to plot time over power, whatever. You can kind of see it. You can save this chart. There's lots of flexibility in here. More so than sputtering, we like to use this if we have thermal evaporation. We have a crystal head where we can look at our PID values, we can look at our ramps, we can really fine tune things. But really handy feature. How you're going to use it in sputtering, I don't know, but I'm sure you'll be able to find a use. You kind of spin down this long side here. So everything that I've kind of showed you so far has been on this operation tab. If I go to the maintenance tab, there's a couple things on here. So one is system information for the tool. So if I open up recipe logs, these are all the recipes that were run on the tool based upon the date code. Alright, so ran all these different recipes. And it's systematic. Every time you run it, it logs it per day. It also, we go to events and other logs. So we hit a bunch of interlocks today. Take a look here. So these are all the events that happen. Once again, this is because it wants us to start a Microsoft Office account. But these are all chronological. And why we like to have this, we like to have the ability, let's say you called us a month from now and said, hey Brian, we're having a problem. We'll say, okay, can you generate a file for us? I'm not sure how to do that, and send it to us. When did it occur? You said, hey, it happened at midnight. And I can look and see if there's a power outage, or maybe you had one user every day at 3 o'clock. It was like the bad user. He's like, I didn't do it. It'll be captured. Everything that happens is captured in here. If they hit an interlock, a recipe, whatever they type in here, whatever value set point is going to be displayed in there. So let me kind of bounce back to that. So exported recipes. I don't think we use that at this point. Not. It's kind of a placeholder. System drawings is also a placeholder. I gave you a hard copy of the drawings. One of the reasons we don't give you the system drawings in an electronic format initially is whenever this is built, we have mechanical and electrical assemblers, two different teams, and as they build the system, one part of our QA checks is someone has a highlighter, a certain color highlighter. So I know who did what part. And if anything's different than what it's drawn as, we have to redline the drawings. We have to determine where the discrepancy is, and we send it back to engineering. They make a correction, and then we give the final drawings. That doesn't occur by the time the system ships. So if I were to put those drawings in, they'd be drawings that were not correct for the system. But back to where I wanted to kind of get to backup-wise. This is a very dangerous button right here, disable interlocks. And it does exactly that. If I click this button, I get an indication here. So any protections I had on the tool are now off limits. So if the turbo's at 100% and I hit turbo vent, you would vent the turbo and probably damage the turbo. Why is it there? Sometimes we need to get around interlocks for troubleshooting. So when we log in, I have the ability to prevent someone from getting to the screen. So I'm going to show you that. So what I like to do, I'm going to turn this back off. Back up the controller. So if I back this up to the controller, it backs up whatever's on this interface of the controller. That's the latest copy. Generate support file is what it was a long explanation for me to get down to there. If I click generate support file, what it does is it grabs all of these items and then puts it in, it compacts it so that you can email us and say, hey, these are the log files, these are the rescue logs, these are the event logs. We don't have to log in if we didn't have TeamViewer access to get to it. You can send it to us and just say, hey, this happened on this date, or this happened. We can go through and say, yeah, this happened here because of, we can help troubleshoot. So there's also a quick start guide for this. maintenance values. So here's where it's going to save it at. All right. So maintenance values. So the first one's cooling status. You notice that you have what we call rotary flow meters. So it's a Hall effect device that'll basically rotate, and as it goes through I guess as the magnet goes through the switch, we can calculate the flow rate. This is also made for what we call a plunger type switch, which is on or off. That's why this is green over here. So this is the actual flow rate. Is this in gallons or liters? I always ask.
I thought it was liters.
Yeah, I'm kind of thinking it is. I asked our guys to put a little legend over here, but they haven't done that yet. But regardless, this flow rate is sufficient, because if you go to my operation screen and I go to deposition, my two flow indicators are green, which means that it has sufficient flow to satisfy the required interlock to turn the output of the control on.
What is the unit for flow rate?
I'm thinking it's liters per minute. Yeah, per minute.
Liter per minute?
Yeah.
LPM?
I think it's a lot.
Yeah, can you? Yeah, there may be a line on there. That's something. It's one of those questions that I always, and I really want some kind of leader thing, some kind of notation. This is in this unit. But we can kind of figure that out. So I mentioned earlier about the maintenance monitors and how we don't really have a true and try value until you determine where your max usage is. So you can see right now it's blinking red, and we got it up here. So this is where that's associated. Sources. These are the hours, kilowatt hours. Valves. These are number of cycles. Pumps. How many hours